Okay, so we're looking at using law of sines and law of cosines to help us solve some applications. And so we were using law of sines when we knew an angle and a side right across from it. And we used law of cosines if we knew two sides and the angle sandwiched in between it, or all three sides. So I was really, really fortunate, and I didn't have to teach last summer, and I got to do one of my long life dreams of traveling and going to Italy. My dad's all Italian, and I've always just had that wanting to go there. So this question just grabbed me because this is Pisa, which we didn't get to go. We're on a train past it, but anyways, I've been seeing, you know, how your phone brings up all the pictures from, you know, recently or that year before or a couple years before. So all the pictures of Italy are coming up right now. So I'm getting a little jealous. So maybe we can do a little problem from Italy and do something else I love, math. Okay, so here we go. You have this famous Leaning Tower. Was originally 180.5 feet high at a distance of 128 feet from the base of the tower. Okay. If the angle of elevation of the top of the tower is found to be 58 degrees, find RPQ. So when they give you an angle, and we haven't really talked about this with three letters like this, this is just saying that you're looking at the angle P, the one that's sandwiched in between. So here, RPQ would be here. So we want to find this angle indicated in the figure. Also find the perpendicular distance from R to PQ. So PQ, when it does this, this is talking about the line PQ. So we're going to want to find this distance in here. Okay, so we already know a couple of things. We know that this right here is 180 feet, or 180.5 feet. And then we also know right here, this is 128 feet. And this angle across here, or here, is 58 degrees. And so we know an angle and a side that are directly across from each other. So that should clue you in to use law of sines. And so we're looking for an angle. And so it's helpful if we use it where we're putting sine of the angle in the numerator instead of down in the denominator. And so we have sine of the 58 degrees all over the side, 180.5 is equal to let's see.
I'm sorry, what was that reason that you said that we should be able to identify that it was like law of sines?
Law of sines, it's because we want to use law of sines when we know an angle and a side directly across from that angle when we're not dealing with right triangles. And so because we're given this angle of 58 degrees and we're given the length of the building is 180.5 degrees, we know the angle and the side across. We also know that this length in here. So actually when I'm doing this, I would actually be first finding, because I know this, the only thing that I can find right now is this angle across from this. But if I know this angle across from this side that we know, then we can figure out what this angle has to be in here, because we know the sum of all three angles has to be 180 degrees. And so we know here that this side is 128 feet. And so let's look at this and let's call it sine of theta. And so we can find out what theta is by multiplying both sides by 128 feet and then taking the sine inverse of both sides. So we have 128 sine of 58 degrees all over 180.5 equals sine of theta. So theta is going to equal the sine inverse of this. So you want to make sure that your calculator is in degrees. And 128, I would probably do first the piece inside the argument and then take the sine inverse of that. So 128 sine of 58, make sure you close off your angle, divide by 180.5. That gives you approximately 0.60. And now take the sine inverse of that answer. And you get theta is approximately 36.969. So we can round that up to approximately, theta is approximately 37 degrees. And so what the angle we want to find, angle RPQ, this is going to equal 180 degrees minus the 58 degrees that were given in that triangle and 37 degrees, which we just found. Which is about 85 degrees. Okay. Now we have one other part of the question. It also wants us to find the perpendicular distance from R to PQ. So it wants us to find, oops, that's a good angle. Just draw the triangle again. Wants us to find this distance, the top down to the ground. Well, we know what this is. This is still 180.5 feet. We now know what this angle is. We just found that it was 85 feet. No, not 85 feet, 85 degrees. We actually, because this is wanting the perpendicular, we can say that this is a right triangle. And so having a right triangle, and we know an angle, and we know the hypotenuse, and we want to find from the angle that we know, we want to find the opposite. So think about which trig function uses that. So sine is of 85 degrees is equal to the opposite of that, maybe call this x, all over the hypotenuse, which is the 180.5 feet. So we can figure out what x is by multiplying both sides by 180.5. So x is equal to 180.5 sine of 85 degrees. So that gives us x is approximately 179.8 feet. or if we round it, 180 feet. Okay, so questions on that one? Okay, so I've chose another problem because it's another place that I love. So finding the height of a bridge over the Royal Gorge. So Royal Gorge is in Colorado Springs, right outside Colorado Springs, someplace that I lived while I did my graduate work. So this is, and I didn't realize this until I read this problem, unless this is false information. No, it says from the source is Guinness Book of World Records. So the highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at the water level directly under the bridge are taken from each side of a 880-foot long bridge, as indicated in the figure. How high is the bridge? Okay. So we have this bridge here. We're given that the bridge's length is 880 feet. You got your cliffs over here. And we get your water down below. And we are looking for the distance. This height. Okay, so let me go back and look again at the information. So it didn't even say anything about the angles, but it just gives it. And so if we look at this triangle down from this side of the bridge, going down to this point in the water, and we look at this angle from this side of the bridge going down to the same point in the water, this is 69.2 over here on the left degrees, and this is 65.5. So how high is the bridge? So how are we going to do this? So first thing I notice is that this is a right triangle. So the first thing I would want to do is just use my right triangle. Let me just see, does it say the highest bridge in the world over the Royal Gorge, sighting to the same point in the water level directly under the bridge are taken from each side of the height. So I guess we don't technically know that this is halfway. So I'm going to assume that we don't know that this is halfway, because if we knew this was halfway, then we could use, I would just go and use my angle opposite, and we know adjacent. So I would just use tangent. So let's say we don't know that this is halfway. So this is where we are going to need some more information. We could figure out, let's see, let me just think. Okay, So we could figure out what this bottom angle is in here because we know that the sum, this one of the big triangle right here, we know that the sum of all three angles has to be 180. So let's look at 180 degrees minus that 69.2 degrees minus the 65.5 degrees. And so if we do that, I get 45.3 degrees. Maybe call it theta. Okay, so now that we know this angle, we also know the side directly across from it. And because we know that, then we can find a length. We can't find this length because this whole thing is directly crossed here, but we can use the information to find one of the lengths over here on the left from the top of the bridge down to this point, or the one on the right down to the point. And it doesn't matter which one you want to use. So let's just look at maybe the left-hand side. Oops, actually no. What did I say? So here we have 180. Here we just found that this was 45.3 degrees. We know that this angle in here on the cross is set 65.5, and this one was 69.2. So again, it doesn't matter which side that we're trying to find. And so if we look at the one on the left, let's call it X. So because I'm trying to find a length of a side, I'm going to put that in the numerator. So I'm trying to find X. That's all over. And when we're looking for a side, and we know a side and an angle across, that's cluing me in to use law of sines. So I have X all over sine of 65.5 degrees is equal to, we know the 880 side all over sine of 45.3. So we can get X if we multiply both sides of our equation by sine of 65.5 degrees. So we have 880 times sine of 65.5 degrees, all divided by this sine of 45.3 degrees. So plugging that in the calculator, 880 sine of 65.5, take that result and divide it by sine of 45.3. And you get that that is, X is approximately 1,126.6 feet. Oops, they go out 2 decimals. So let's do this as 57 feet. So we just found what this length was in here. We want to find, so here we know that this right here, this was 1,126.57 feet. So if we know this, we have the angle across from the length that we want, that height from the bridge to the water that they were both looking down at. So I don't know, let's call this maybe Y. So looking for Y, I'm looking again for a length. And so I'm going to use law of sines, and I'm going to put the length of the side in the numerator. So I have Y all over sine of 69.2 degrees is equal to, oh, actually, we don't even have to do that, guys. That's kind of overkill. Let's not even do that. We now know that this is a right triangle. We have the hypotenuse. We're trying to find, if we look at the 69.2 degrees, we're trying to find the opposite. So opposite and hypotenuse tells me that I can use sine. So I have sine of 69.2 degrees is equal to the opposite, which is y, all over the hypotenuse, which we just found was 1,126.57 feet. So multiply both sides by that denominator, and then we get what our height is, what we're trying to find. So y is equal to 1,126.57 feet times sine of 69.2. Okay, I didn't round when I put the, I already have the answer in my calculator without rounding, so I didn't do that when I multiplied sine of 69.2, and I got y as approximately, so yours might be a little different if you had rounded, 1,053.15 feet. Okay, so that height of the highest bridge, according to the Book of World Records, this could have been outdated, who knows, is 1,053 feet, 0.15 feet. So questions on that one?
What was it that told you that it was a right triangle again? So you could put the 90.
Yeah, because I was looking, we wanted from the bridge, we wanted that height directly above that piece that was in the water that you were citing on each side. And so I know that that would form a right triangle or a right triangle with this. But I couldn't use that until the very end because I didn't have information before to do that. Because I didn't know that this technically, I didn't know if this was halfway on the bridge or maybe this could have been shifted over where it looks like it's half, but it could have been shifted over here. We know that this length is still 880, but this would have been directly down to where the water was. And this would form a right triangle, but okay. So a lot of these, once you've used one of the laws, sometimes you use law of cosines and then you'll find some information, and then using law of sines is a lot easier and faster. And once you've used that law of cosines, you can do that same sort of idea here, where once we use the law of sines to help us to find a bit of the information of the triangle, we could make it a right triangle and find the piece that we needed to. Okay, so we're gonna now go on a flight. So an airplane flies due north from Fort Myers to Sarasota, a distance of 150 miles, and then turns through an angle of 50 degrees and flies to Orlando, a distance of 100 miles. So you should be able to set up pictures. This one did show a figure, but let's just walk through it and not even look at the figure. So an airplane flies due north from Fort Myers to Sarasota. So let's just start writing a picture. So we got Fort Myers. So due north is going to go up. And it's flying to Sarasota. And it told us that the distance it flew was 150 miles. So we know that this length here is 150. And then turns through an angle of 50 degrees. Okay, so your plane is here. Let's look at it. And if you are turning 50 degrees, let's look at the horizontal. So if you turn 50 degrees, that's about here. Okay, and then it tells us that they flew 100 miles. So whenever they're giving me directions and it's something and it turns direction, I kind of make my little cross area so I can figure out how that would look. So let's just assume then this right here is the point for Sarasota. But basically they turned this 50 degrees and then they started. They then reach Orlando. Probably a place of another favorite of mine. I don't know yet, I haven't been to Disney World. But Disneyland. Okay. There's our picture. So now let's answer a question. So how far is it directly from Fort Myers to Orlando? Fort Myers, so how far is it from here to here? Okay, so with our picture, we know actually two sides. We know this is 150 miles, and we know that this side right here, this was 100 miles. We have this angle in here, and we actually can figure out what this angle inside the triangle is. We know that if we look at the straight line right up here, that whole thing is 180 degrees minus this 50 degrees that we had turned. And so this angle in here is 180 degrees minus that 50 degrees. So that angle in here is equal to 130 degrees. So we don't have a right triangle. We have an angle and we have the sides that sandwich the angle given. And so this is where we're going to use law of cosines. I don't know what we want to call it. Maybe A. Okay, so law of cosine says the length A squared is equal to the sum of the square of the other legs. So 150 or sides, 150 squared plus 100 squared minus 2 times those sides that you know that we're sandwiching it, 150 times 100, cosine of the angle across what you're trying to find, which we said was 130 degrees. Okay, so we have A squared then is equal to 150 squared. Well, 15 times 15 is 225 plus 2 more zeros. So that's 22,500 plus 100 squared. So there's 4 zeros. So that's 10,000 minus, well, 2 times 15 is 30. And then we have 1, 2, 3 more zeros. 1, 2, 3. 30,000. Cosine of, this is not one that we know, 130 degrees to get up to the x-axis from there, or going down, would be 50 degrees, which we don't know. So I'm going to use my calculator. So I'm going to plug that in, 22,500 plus 10,000 minus 30,000 times cosine of 130. So I get a squared is approximately 51,783.63. But I don't want a squared, I want a, so take the square root of both sides. I'm not going to round it in my calculator, I already have the answer, so I'm going to just take the square root of my answer. And so doing that, we get 227.56 miles. Okay, so that was part A. Part B asks, what is the bearing should the flight pilot use to fly directly from Fort Myers to Orlando? Okay. So what bearing? Should you use to go from Fort Myers to Orlando? Okay, so they're going to take off instead of going to Saratoga first and then Orlando. They want to know if we take off here and just go directly to Orlando, what is the bearing that they have to fly? So we need to figure out basically this angle in here. So how can we figure out that angle in here? I don't know, what do we want to call theta? Okay, well, we don't have a right triangle. We have a side opposite of the triangle that we want, or yeah, we have the side opposite than the angle that we want. And we now know, because we found this distance, we now know an angle and a side across. And so if we have an angle and a side across, then you should use law of sines. So law of sines, I'm going to take sine of theta all over the side directly across from it was 100 is equal to sine of the angle in here, which was 130 degrees, all over the side. And the side we just found to be 227.56 miles. So multiply both sides by multiply both sides by 100, and then we're going to take sine inverse to figure out what theta is. So theta is going to be sine inverse of 100 times sine of 130 all over this 227.56. So 100 sine of 130, divide that answer by 227.56, take that result and plug it into sine inverse of that. So theta is approximately 19.7 degrees. Okay, so there was different ways that we could give directions. We talked about there was just the bearing. If you were just starting with a bearing, that would just be going from the vertical clockwise. So we could just say this is a bearing of 19.7 degrees. Or we could even give a little more direction in the fact, or I guess that's the same direction. We also talked about where we either started on the north or south and told what direction we went. So if we're starting on the north here and we're going towards the east. And so we can say that the direction is going to be north 19.7 degrees east. Okay, so those were some examples of law of sines, law of cosines. 9.4, and I'll give you any of these formulas if we need them for the final. So this one right here, so I'm not saying I'm giving you law of sine, law of cosine. I'm going to give you the area of triangles.
What chapter was this again? 7? Or
I'm sorry if I keep on saying 7 because that was what the chapter was in the old book. This is chapter 9.
9 point what though?
We just kind of reviewed just the application part of 9.2
Okay.
and 9.3. And so we had done the mechanics of the math before yesterday. So just kind of reviewing that with applications.
Okay.
This right now is 9.4. So we haven't talked about any of 9.4 yet. And it's area of triangles. We don't necessarily know that it's a right triangle. And so if we don't know it's a right triangle, then we can use these theorems. And there's this theorem that says if you know SAS. So I haven't really been going through this because I just said, let's just look at the information and find our things. But this is basically saying that I know a side, the angle, and then the side. So basically this would be saying, this would be using law of cosines if I had to find some information. But for area, if you have SAS, then the area, and I don't know why they're using K, very K for area, but they say K is equal to, sorry, theorem SAS for the area of a triangle. K is equal to 1/2 times AB cosine. Nope, sorry, not cosine, sine of C. Or 1/2 BC sine of A. Or 1/2 AC sine of B. Okay, depends on which, side sides. This is the angle that's sandwiched in between the two sides that you know. So there's another theorem, and it's Heron's theorem. And this theorem will help us if we know 3 sides of a triangle and we want to find the area. So Heron's theorem is given or used when you know 3 sides of the triangle. or just know. The three sides of the triangle. Okay, part of our theorem in here is that we have to figure out what S is. S is equal to half of the sum of all three sides. So A plus B plus C. And once you figure that out, we can use it to find the formula or find the area of that triangle. And K is equal to the square root of this length S, all times S minus A, that length minus the side A, S minus B, and S minus C. All of those multiply together. Okay, so with that information, we're going to just look at some problems. So find the area of each triangle. So if you were given A equals 4, B equals 3, and C is equal to 6. So they're all lowercase. That tells me that those are just lengths of the triangle. I don't know any angle, and so I would have to use Heron's theorem. First, I would figure out what S is. S is going to equal, again, half of the sum of all the sides. So 4 plus 3 plus 6. 4 plus 3 is 7 plus 6 is 13. So this gives me 13 halves. So I know K, the area of the triangle, is equal to the square root of 13 halves. And then I have 13 halves minus A. I'm going to need a common denominator, so we might as well do it now. So that is 8 halves. And then we have S, which is 13 halves, minus B. But I need a common denominator, so this is the same thing as 6 halves. And then and then times S, 13 halves, minus C. Again, let's get a common denominator, and so that would be 12 halves. So minus 12 halves. Okay, so 13 halves, all times 13 halves minus 8 halves. Well, 13 minus 8, that's 5, so that's 5 halves. All times 13 minus 6, that's 7 halves. All times 13 minus 12, that's 1 half. So none of these have like factors, so we're not going to be able to pull anything out of the numerator. But we have 13 times 5, times 7, times 1. So that's 455 in the numerator, all over, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. This is the square root of 455 all over, square root of 16 is 4. So that's exact form. Estimated form is about 5.33. Didn't say anything about units, so I'm just going to leave it like that. Okay, this is actually a cool one too, and I think I've given this one before on an exam. Probably similar, maybe the same problem. So the Bermuda Triangle. The Bermuda Triangle is roughly defined by Hamilton, Bermuda, San Juan, Puerto Rico, and Fort Lauderdale, Florida. A distance from Hamilton to Fort Lauderdale to San Juan, and San Juan to Hamilton are approximately 1,028, 1,046, and 96.5 miles, respectively. Ignoring the curvature of the Earth, approximate the area of the Bermuda Triangle. So basically, it's given us, again, all three sides of the triangle. It's given us that one length is 1,028 miles, one is 1,046, and one is 965 miles. And so we want to, again, figure out what S is. So S is equal to 1/2 times the sum of all the sides. So let's see what we get. So 1,028 plus 1,046 plus 965 divided by 2 gives me 151.9.5. I guess we could have left it in 0.5 before instead of fraction. So now we want to look at our formula. So the square root of S, 1,519.5, that minus the side. So 1,519.5 minus 1,028. Take that 1,519.5 minus the other side, 1,046 times that 1,519.5 minus 965. I don't know if you just want to throw that in the calculator. From there, we could find the differences. First difference is 491.5. Second distance is 473.5. And 554.5. Huge. And now let me take the square root of that result. Four, 2, 8, 1, 5. And it went up to the nearest mile. So it's 0.5 is next. So this, it would round up to a 6. So that's 442,816 square miles. Any questions on that? Okay, so far we've looked at, probably in your mathematical career, is only looking at Cartesian coordinates, plotting on the XY axis. And now we're going to look at a new way to plot points, and this is called the polar coordinates. Couple things that you need to know is that point here, kind of like the point that is our origin, this point here is called the pole. And then you have this horizontal line going in the direction to the right. And this is called the pole axis. So before we're plotting points, they were in the form of X, Y, right? And so when we're plotting points for on the polar coordinates, they're in the form of r theta, or sorry, let me look. Yeah, r theta. So r is the distance from the pole to the point, and theta is the angle from the polar axis. So for instance, if you were given plot 2 and 30 degrees. Let me see if they do any of these in degrees. Most of these I'm looking at are in radians, so let me just see. No, so they're all in radians, so they might have to be real numbers. And so let's do pi 6 then. Okay, so you're going to go to your pole. Basically what you're going to do, and you can look at paper online, and if you look at it, the polar axes, polar coordinates, it looks like that you have these little circles that expand out from the pole. And so basically it looks like this, and I can't draw. But they're the equal distance between each circumference of the circle. So doing this, you're going to go from the pole. You don't have to have this X or Y axis. I kind of just do that anyways. And you're going to use the direction pi 6. So we've been doing stuff like this before. Rotate pi 6. So go pi 6. And then we're going to count up from pi 6, 2. And so because it's r is 2, so we go 1, 2. So this would be our point right here.
So is that showing that pi 6 goes out to the second circle?
Yes, and it's going to the second circle because of the 2. So this is how many circles you're going to go out from that pole to that angle. So if I swiped pi 6, that would be this line, and then I would go out 2 from there, from the pole to get that point. So this is the number of circles if r is bigger than 0. So it's in the form of r theta. This is the number of circles. You would go out from the pole.
Oh, hold on, I got confused again. So what was the pi 6 part?
And the pi 6, that's what angle you're going to swipe to know how many places to go from up to that line. So this is the angle that you're going to swipe. So this angle gives you the direction of where to go starting on that line, going up, counting that number of circles. So for instance, so let's look at another one. And I didn't do any negatives yet. We'll talk about negative in a moment. So let's say it was 11 pi 6. So really the first thing that you want to do is you want to locate that line, or think of it like your terminal side of that angle. Locate that terminal side of that angle, and then the R will tell you how many circles to go up or actually down, depending if it's positive or negative from that angle. And so here, first thing you would do is do your 11 pi 6. Well, I notice this is almost 12 pi 6, which is 2 pi. So I know I'm doing a rotation. I'm going to be in the 4th quadrant. And so this is 11 pi 6. And then from there, this 4 tells us how many circles we would go out. And so basically we could just write that like this: 1, 2, 3, 4. We had made circles like this. That's how far we're going. So our point would be here. This length in here is 4. And this angle gives us where to locate where that point is. So it's just a way to help us locate where the point is on this axis, just like X and Y kind of gave us directions on how to plot that point. So if R is less than 0, then instead of going in the direction that that angle gave you, you're going to go in the opposite direction. And so for instance, if this had been negative 11 pi 6, so instead I would do my 11 pi 6 again. It would rotate me here. Instead, this line though, let's extend it left and right. So if I extended this line, right? So instead, I'm going 4 in the opposite direction if it's negative. So I'm going to go up. So 1, 2, 3, 4. So just like when we were, basically we were kind of looking at points like this before. So when we were looking at, terminal sides of an angle, we were saying that before there was multiple ways to get to that terminal sides by adding 2 pi to it. Same sort of idea here. So there's an infinite number of ways that we could rewrite this point and get in the same place. And so let's look at another way to write this point. So find a point that would land in the same place. -4, 11 pi 6. Okay, so if it doesn't give me any information, there's infinite ones that I can find, and we can actually find the formula for this too if we wanted to. But let's first think about it this way. Let's look at the one that, what is the angle that would get us from here to here? Well, do we know what this angle is in here? So this was 11 pi 6. And so basically we have a pi 6 left here. That would have been our reference angle. Angles that are directly across like this, they're congruent. So this is actually a pi 6 right here. And so we can figure out what this green angle is by pi minus this pi 6. So 6 pi 6 minus pi 6 gives me 5 pi 6. So 5 pi 6, that would work. And since I did it this way and I want it to go up from here, I would have to have it a +4. So basically I could get this by saying 4. And if I added any multiple of 2 pi to that, 2 pi k. K is an integer. Or another way, what about this -4? 11 pi 6. If we added any multiple, right? Plus 2 pi k. 2 pi. That would also get us there. So those, we found the formula that would get us any point that would get us there. So it just says plot each point given the polar coordinates. So if you're given -2, -pi. I would start here, just like we would do with our standard side. Initial side, I would go -pi, which is the opposite direction. That would get me over here to the negative x-axis. But it's telling me that I'm going -2. So if I'm going -2, I'm going to go the opposite direction too. So our point would be here. Okay, so plot each point in the polar coordinate. Find the other polar coordinates, r theta, of the points for which r is greater than 0 and theta is between -2 pi and 0. Plot points and find other points in the form where r is greater than 0 and it's between -2 pi less than or equal to theta is less than or equal to 0. So if we're looking at 3 pi fourth. So first plot it. 3 pi fourths, it's positive. So we're going to go positive direction, or not positive, counterclockwise direction, 3 pi fourths. That's going to bring us into the second quadrant. From there, we can draw a line. And it tells us that we're going to go 4. So that point would be right here. So other ones, we have to find, we want our angle, it says between -2 pi and 0. So that's telling me that it wants me to rotate in the opposite direction. And it wants my R value to be positive. So I can't go down here and then put a -4 and go up. So I'm gonna need to rotate in this direction. So this is pi, and I need to figure out what that distance is from the negative x-axis up to this terminal side. Well, if this is 3 pi fourths, my reference angle would have been pi fourths. So pi fourths plus pi, 4 pi fourths plus 1 pi fourths, that's 5 pi fourths. But I'm going in the clockwise direction, so it's -5 pi fourths. And then we wanted our R value to be positive, so 4. Okay, so we plotted the point and we found another point with the information that they asked us to. So let's say we want to go backwards. Let's say you're given a polar coordinate what we want is to find rectangular coordinates of each. Find the rectangular coordinates. So pretty much what we're going to do right now is what we were doing pretty much a lot of our class. And so we're going to look at the directions, we're going to plot that point, and then we're going to form a right triangle with the closest x-axis. And then we can find our x value and our y value given the information. And so let's say they want you to do that with five and 5 pi thirds. Okay, so I have to locate where 5 pi thirds is. I notice that this is almost 2 pi. If I add a pi thirds here, that would get me up to 6 pi thirds, which is 2 pi. So that tells me I'm going to be falling in my fourth quadrant. with a reference angle pi thirds, which is 60 degrees, so about here. And we're going to go out 5. So let's just count 5. 1, 2, 3, 4, 5. Okay, so let's look at what we have. Let's form a triangle. So let's make a right triangle with the x-axis, always with the x-axis, closest one to us. We know what this length there is, our hypotenuse. This r value was 5. We know what our reference angle is. To get up here to the 2 pi, we would have had to add another pi thirds. So think about which trig function would use your hypotenuse if we wanted to get this y value. So this y value of our point from pi thirds is opposite, and we're using hypotenuse. So we know that sine of our angle pi thirds is equal to the opposite y all over our hypotenuse, which we know is 5. So I can get y by 5 times sine of pi thirds. So 5 times, so I have to think to myself, pi thirds. I also have to think about what quadrant. So this is my reference angle technically. So sine of 5 pi thirds, that's going to be, or I technically could put in here, this might even be better, sine of that 5 pi thirds, what we started with. So anyways, pi thirds, that's root 3 over 2 for sine. And so we have 5 times root 3 over 2, but we're in the fourth quadrant. Fourth quadrant, y is negative. And so y is going to equal negative 5 times root 3 over 2. Or negative 5 root 3 in the numerator all over 2. So we want to also find out what the x value is at that point. Well, let's think about our right triangle again. We know what our angle is. We're trying to find the adjacent side, and we have the hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. So we know cosine of our angle, pi thirds, again in quadrant 4. Is equal to adjacent, which is x, all over our r value, which is 5. So we have multiply both sides by 5. So we have 5 cosine of pi thirds equals x. So x is equal to 5 times cosine of pi thirds is 1/2. So this is equal to 5/2. So our point that would get us there is 5/2, and x has to be positive because it's in the fourth quadrant. And then our y value was that 5 root 3 over 2, negative 5 root 3. So I don't know if you noticed this, but this y value, that y coordinate, doesn't matter where we are. Basically, to get this y value, you're going to have to look at sine of your angle. That would give you your y value over r. So notice that. Sine theta is equal to y over r. And so y can be represented as r times sine theta. Same sort of idea with our x value. If we go out our angle, form our triangle, to get this x value, doesn't matter where we are, where are the triangle legs, but to get that x value, it's always going to be the adjacent over hypotenuse. Adjacent over hypotenuse is going to be cosine. Theta equals x over r. So x has to be, multiply both sides by r cosine theta. To me, it makes more sense just to go through and plot it and make the triangle than just starting to plug in these numbers into a formula and not understanding what I'm getting. There's another thing that's also helpful. Let's think about this right here, tangent. That help us. Tangent theta is y over r. No, y over x. R squared equals x squared plus y squared. Okay. So we pretty much just showed if you have a point, xy, that can be converted, r theta. Well, x is equal to r cosine theta, and y is equal to r sine theta. R squared equals x squared plus y squared. If I wanted to figure out what theta is, if we know what y and x is, tangent is what uses y and x. And so I could take the tangent inverse of both sides, and I can say then tangent inverse of y over x is going to equal theta. Got to be careful where it's undefined with that y-axis. Let's say you had -6, negative pi fourths. And I wanted you to, again, plot that and find the rectangular coordinates for the point. so negative pi force, that tells us that we're going to go in the clockwise position, starting at our pole axes, and we're going to go pi force. So from there, we're going to draw our line. And then -6. So instead of going down here in the fourth quadrant where the negative pi force laid, I'm going to go in the opposite direction, 6. So we have the point right here, and we know that this length in here is 6. So if we form our right triangle with the x-axis, here we have our theta inside. We know what theta is. It's our reference angle, which is pi force. And we're in quadrant 2, so we have to be careful about the signs of our x and y, or trig functions. And so we know that x, again, is equal to r times cosine theta. Or another way to look at it is cosine theta, which is pi force, is equal to the adjacent side, which is x, all over the hypotenuse, which is 6. Multiply both sides by 6, we get x equals 6 cosine of, it's really technically 5 pi force, not 5 pi force, whatever. It's a negative. What I'm trying to get out is it's negative because we're in quadrant 2 and x is negative there. So this is going to give me cosine of pi force is -√2/2. So x is equal to 2 goes into 6 3 times, so we got -3√2. To figure out what the y value is, I just look at my angle. I know I'm in the second quadrant, sine is positive. So I know that sine of my reference angle pi force is equal to the opposite, let's just call it y, because that's the length of y, all over hypotenuse of 6. So y is equal to 6 times sine pi force in the second quadrant. So it is 6 times +√2/2, which reduces to 3√2/2. So we got a point -3, oops, not over 2, and reduced. So -3√2 is our x value and +3√2 is our y value. But if you wanted to memorize it, you could have just thrown that into x equals our cosine theta. You are given x is equal to, this is your r value, -6 cosine of theta, negative pi force. Cosine is an even function. So this is the same thing as x is equal to -6 cosine of pi force, which is -6√2/2 times, which is -3√2. Which we got here. Same thing, y is r. We multiply both sides by r. sine of our angle. If you had done that, so y equals 6, right? No, it was -6. Sine of negative pi force. Remember, sine is odd. So it's the same thing as the negative of that. So negative of negative sine of pi force. So that's a positive, and sine of pi force. Oops, where did my 6 go? Don't drop the 6. So pulling that negative of the negative out. So that's positive 6. Sine of pi fourth is √2/2, which again is 3√2. So again, I wouldn't have it memorized. I would go and I would look at it. So you should go the opposite direction. Given the point, you should be able to find r, and you should be able to find theta. So if you just kind of put together what we've been doing from the beginning, it all kind of falls out. And so if we want to look at 1, -1, let's do it maybe a little harder. Let's do a little harder maybe. How about 5, 5√3? So the rectangular coordinates of the point are given. Find the coordinates for each point. Polar coordinate. For each point. Okay, so I think the best thing to do is you need to graph it. That way you know which quadrant you're following in. And so if we go over 5, and then we go up 5√3. √3 falls in between square root of 1 and square root of 4, so it's 1 point something. So I can kind of get an estimate, but let me just plug it in. So I get about 8.7. Just so it helps me to graph it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's our point. We can form our triangle. We know what our x, this base is. This is our x value, which is 5. And we know what our y value is, which is 5√3. And we want to figure out what this theta is. Well, think about which trig function uses opposite and adjacent. And so we know tangent theta then is opposite 5√3 all over 5. 5's cancel. So we're looking at when is tangent theta equal to √3. This one doesn't have as many 3's in it, so that's the 60 degrees or the pi thirds. And we're in quadrant 1. If I had something different and I had pi thirds, I'd have to think about what quadrant I'm in.
You couldn't have used the 8.7 that you had found?
No, I don't want to do that because you probably won't have a calculator. I just wanted that 8.7 so I knew exactly where on my y-axis to go because I didn't know what 5 times √3 was. And so you wouldn't have noticed, if you put that in your calculator, you wouldn't have noticed that was one that you knew. And then R is this length. Well, Pythagorean theorem. We have our two legs, and so we know that R squared then is the same thing as 5 quantity squared plus the other leg quantity squared. So we know R squared is equal to 25 plus 5 times 5, 25. Square root of 3 squared is 3. So R squared is 25. 25 times 3 is 75. R squared is 100. So that means R has to be 10. So we just found the point, polar coordinate, that would be the same as that rectangular coordinate of 5 root 3. R comes first in the point, so 10, comma, pi thirds. Should we do one more? Actually, let's do one like this. Let's say you're given an equation. So the letters x and y represent coordinates. Find the equation using polar coordinates r theta. So this is kind of getting us ready for the next section, and I'm going to just go over the next section, 10.2, really lightly. I just kind of want to give you the idea of how cool these graphs can look. It's just that we don't have the time, and I normally don't have the time to get into it as detailed as the book does. But basically, we can take equations that are in rectangular coordinates and rewrite it to be in polar coordinates. So if you have the following equation, let's say x squared plus y squared is equal to x. Okay, so if we graph this, hopefully you know what the shape of this graph is. This is a circle. I can tell it's a circle because I have an x squared and a y squared, and my numbers in front of my x squared and y squared are the exact same number. But I want to rewrite this in rectangular coordinates. And so this is actually where it is kind of helpful to know the certain things. That your x value is equal to r cosine theta. Your y value is r sine theta. X squared plus y squared equals r squared, and tangent theta, or theta equals tan inverse y over x. So notice in our equation, we have x squared plus y squared. If we look over here, x squared plus y squared, it's the same thing as r squared. So we can just replace this x squared plus y squared with r squared. So now we have this r squared is equal to just x, but we want this all in terms of r and theta. And if you look at that, x is the same thing as r cosine theta. So we have really r squared is equal to r cosine theta. I don't know why they do this, but they have their answer where they only have a single r. So if we divided both sides by r, we get r equals cosine theta. yeah, add x squared is equal to 4y. So looking at this in the rectangular coordinate, I can tell that this is a parabola. If I divide both sides by 4, this is 1/4 x squared, so it's a parabola facing upwards. We can rewrite this in polar form. And so we know what x squared, well, that would be the same thing as r cosine theta, quantity squared, which is equal to 4 times y, but y is the same thing here as r sine theta. Oops, r sine theta.
Did you say like these equation E ones are like 10.2, or is it that you're still going to go over 10.2 and this is just leading to it?
This is just leading to 10.2, and I will do a little bit of 10.2 on Monday. But this kind of leads to it and the cool graphs that you can get by looking at these polar coordinates. You get like flowers and hearts, and it's really kind of neat. So it's kind of cool just so that you have that idea that it's out there. But we won't get too into detail with it. So basically, you are going to use that equation with x is in terms of r cosine theta, y is in terms of r sine theta. Recognizing x squared plus y squared in there is r squared is helpful. So going in this direction, I just went in and I just wrote my piece. I'm going to square this. This is the same thing as r squared cosine squared theta equals 4r sine theta. Just look at what their equation is. It's not in there. So my guess is they try to get in the form, like a lot of times we try to get our equations in the form of y equals. So I think the same thing idea that they're trying to do here is to get this in the form of r equals. And if we divide both sides by cosine squared theta, we get r squared is equal to 4r cosine sine theta cosine squared theta. If I do the same sort of idea that I did up here, and I divided both sides by r, or if I multiply by both sides by 1 over r, this gives us r is equal to 4 sine theta all over cosine squared theta. And I'm not sure if they wrote that as a single trig function. We could do that. That's the same thing as sine theta over cosine theta, which is tan theta, and times 1 over cosine theta, which is secant theta. Let me just see what the answer in the back of the book is. But if we wanted to leave it in terms of sine and cosine, that's how it would be. Okay. Okay, so that's a good spot to stop. I'm going to stop the video, but I'm going to check the answer. I'll let you know if it changed.